Yeah, so this session is going to conduct by Murugesan. So he is also like you guys. So I contacted him. Sorry, I contacted him in LinkedIn. So I, based on his profile, I requested him to conduct one session on his experience, what he has experience on mainframe modernization. So based on my request, he came forward. Yeah, Murugesan, there is a noise. There is a noise. Okay, can you check it? Yeah. So based on my request, he came forward. He agreed to conduct the session or webinar or knowledge sharing on mainframe modernization topic called rebuild. In the similar way, if somebody is interested to deliver on any other topic, not only mainframe modernization, any topic you take apart from vanilla skills, optimization, DB2 training, okay, or anything you feel which is a very interesting, very useful for everyone. And if somebody asking an interview, if you want to share any such as, you please connect with me. I hope you know about me. I am Venkat since 2010, my YouTube channel. So you please contact me so that we can collaboratively we can plan and deliver the session either for free of cost like now Murigation came forward. He is going to conduct without charging any money from me or from you as well as. So if you guys also interested to deliver for free of cost or if you want to charge some amount by conducting some advanced stuff end to end, you let me know. We can discuss, we can plan based on the topic which you choose. Okay, so I'm requesting again, if someone is interested to deliver. Murugesan, there is we are getting noise from your kid. Sorry, I know.
Okay, it's
I don't know how you
okay.
manage because when you are speaking, it will be a lot of problem. Okay, if I am
Let me
speaking,
close the windows. Yeah,
yeah,
give me 1 minute. Let me close all windows.
yeah, you can. Okay, guys. Okay, I'm requesting one more time. Okay, so we need our mainframe community, mainframe resources support to conduct some like this type of sessions on weekend, once in twice. We can take any topic which is very interesting and important for everyone. We can deliver at like a best practices, optimization, something which is not a routine. Okay, so you just please connect with me. You need to do only one thing: come and deliver. That's all. Yeah. So that's all from my end. Okay, I don't want to waste your time. Thanks, Murugesan, for accepting my request and came forward to deliver. So over to you.
Yeah, thank you, Venkat, for the intro. Also, thanks for organizing this session. Good morning, everyone. Like, I will give my small intro about me. Like, I have 9+ years of experience in mainframe application development, also in production support. And from last 3 years, I am working on mainframe modernization. Also, I have work experience on Java. This will be like a very small experience, like 6 months to 1 year. I have work experience in Java also. So today we will discuss about the mainframe modernization, the rebuild approach. So let's move on to the agenda today. Today's agenda. So like today we will discuss like what is rebuild and what are the steps involved and the benefits and challenges, and we will see one use case or example at the end. So what is rebuild? So rebuild is like rewriting the old mainframe programs into the new technology. So it's kind of like we are going to rewrite what we have in the mainframe. It can be COBOL or JCL. So we are going to rewrite that into the new technology. And one more thing is like we are not going to rewrite everything, whatever we have in the COBOL or JCL. We are not going to rewrite everything. We are going to rewrite only the required functionality. So it includes like redundant code. We can say like there are redundant codes on the mainframe or in the COBOL. So those things we can avoid, or some functionalities might be discontinued. There are some functionality might be discontinued on 6 months before or 1 year before. but still the code is still the running mainframe code still running in the mainframe. So those kind of things we can avoid when we are migrating the technology, when we are modernizing this to this on rebuild approach. So this is like more optimized code we are going to rewrite in the new language. And this includes even the database also. So in the database we can see there are many redundant information will be stored in the database, or duplicate columns we can see the same information will be available in multiple places. Or one more thing is like the information is available in db2 but it never be used in any of the application. So those kind of things we can avoid. We can only build the table in new system, only what are the columns needed, only those we can build it in the new system. So we can say like this is very optimized design we can say when we are working on rebuild. Let's move on to the next slide. So here we will see what are the steps involved in the rebuild. The first step, so the first step is we need to study the current mainframe application and the dependency. So the rebuild, we are going to rewrite everything from the scratch. So to rewrite, we need to know what is happening in the mainframe. What are the dependencies we have? Dependency in the sense, for example, we are working for one application, we write some mainframe file that goes to the downstream application, or we write some table. That table is accessed by many other peoples within organization. So all those dependencies we need to identify, and we need to come up with the plan like these are the dependencies we have. So we might be getting data from the upstream system also, it might be from file or mq. So all those things we need to consider and we need to plan. These are the dependencies we have, and also we need to study the current application. So the study means it includes, it not only includes COBOL and GCL, it includes the table also. We need to study the table, how many tables we have, how many tables we required in the new state. For example, in the current mainframe application we have 10 tables. Each table is having 50 columns, so total 500 columns it will be. So we need to see, do we need all 500 columns in the new state? That is one question. Second, we need to see how many redundant columns we have. Same information might be there in multiple places. So we can avoid all those. And third thing is like we can avoid the unused columns. So in mainframe, we can see the information is stored, but it never used. So those kind of things also we can exclude. So these are the things we need to cover in the first place. So like studying the current mainframe application, and we need to identify the dependency. And the second one is identify the essential functionality for modernization. So within the application, there might be a multiple functionality. So we will not be more able to modernize everything in a single shot. So we have to go with one by one functionality. We need to identify which functionality we are going to modernize first. So we need to see who is giving the data to us on that for that functionality. Might be we are getting data from some upstream system on the MQ or mainframe file, and we might be providing data to the downstream system. We need to see whether upstream system is ready for the modernization. We are ready for modernization, we can work on the modernization, but upstream system also has to give the data in the modern route, so that we can consume that in the modern route and have it in the modern system. And the same thing can goes to the downstream system also. So we need to identify the functionality. And the third is we need to build the new database and table structure. So in the first point, we are analyzing the current application. It includes the table analysis also. So we are going to analyze how many tables we have. So we need to decide how many tables we are going to create in the new database. For example, 10 tables we have in the mainframe. All 10 tables is not necessary in the new application. Might be two tables or three tables. Within three tables we can achieve all the, we can store all the information. So that design we need to do, and we need to build a new table structure. And the fourth one is since we build the table, we can start coding the functionality from the scratch. So in the second place, in the second point, whatever the functionality we identified, we can start coding that functionality from the scratch. And the fifth one is we need to perform integration testing with cross-functional team. So we did the coding from the scratch. We need to test that functionality with the upstream system, whoever is giving the data to us, and which are the systems consuming data from our application. So we need to involve all the applications. We need to do the integration testing. And the sixth one is we did the integration testing. If we are good with the integration testing, we can go with the
Testing.
prod deployment. Yeah, someone is asking something. Okay. If the fifth point, we are going to do the integration testing with the cross-functional systems, and in the sixth point, we can do the data comparison between old and new system. So we will be getting data from the upstream system in the new route and old route. Parallelly, we will be getting the data. So we need to compare the data between new and old system to make sure the data is like the quality of data is good, because whenever we start getting the data from upstream on the new route, so we can't use the data straight away because we don't know the quality of data. We don't know what is the impact it will create when we start using the data. So we need to compare the data between a old system is the mainframe, and a new system is the new application. So we need to make sure the data quality is matching with old system, and the data is reliable. So in that scenario, we can move forward. We can start consuming the data from new system, and we can stop the old system integration. And the seventh one is we need to plan for data migration when we are going for deployment to the production. So we need to do the data migration before even going to deployment. Whatever data exists in the mainframe, migrate all those data to the new system and enable the new route. Whatever application we modernize, whatever functionality we modernize, enable the new route, so that the data will be flowing through the new route instead of coming it from mainframe. And the last one is providing ongoing support and maintenance. So we need to continue monitor, since this approach is like we are building newly from the scratch. We required lots of validation, lots of testing required, and also even after deployment, we need to do continuous support and continue monitoring is needed in this approach. Okay, moving to the next slide, we will see the benefits of the rebuild approach. So the first one is cost saving. Since we are moving completely out of mainframe, so it's like even we are moving out of DB2, also we are moving out of mainframe programs and JCLs. So it's like a cost saving, we can say. The second one is real-time data processing. For example, the mainframe application is batch jobs. There are applications running on batch processing. So we know, right, batch processing will run certain times in a day, like 5 times a day, 10 times a day. So when we migrate those applications into the new technology, so it will be a real-time data. When we get the data from upstream system, it will be immediately picked, processed to downstream. So it will happen in the real time. And enhanced flexibility, the next one. So this is like when we modernize our application, it's like more adaptable for business need. If any new functionality need to be implemented, or if we need to send our data to any external system, so this is easier to achieve when we modernize our application. And the fourth one is increased efficiency. Since we are going to optimize our code, when we are going to rewrite, we are going to optimize our code. So it's like a more optimized code, we can say. So we are going to eliminate redundant code or unused or like expired codes. We are going to exclude everything. So it's like optimized application, we can say. And the fifth one is enhanced user experience. Even if it is a customer facing UI, or like even the business user, even the UI is used by the business users. For example, currently the business user is using multiple UIs, to do some certain operation. So in the modernized approach, we can make it optimized. So in single UI, the business user can do that certain operations. So it will like reduce their time. Earlier business user want to switch between multiple screens to do certain operation. It will take 5 minutes for them to do certain transaction or certain operations. So now we are making it to the single UI everything, so they it will be like they can do it in 1 or 2 minutes. So it's improving their experience as well. And moving to the challenges, the complexity of legacy system, that is one big challenge. So understanding the legacy system is a very big challenge here, because the one who written the mainframe code, they will not be working on the company, they might have retired. So the one who knows the functionality, it's like very difficult to find within a team. So to do the rebuild, we should understand the legacy system completely, what is happening in the system we should understand completely, then only we are able to rebuild. Otherwise we will miss writing some functionality that might impact some business operation. And second one is interruption, integration with existing system. So the if we see the mainframe application, it's like integrated with multiple system. If we are working for one application, it will get data from multiple systems. Also we provide data to the multiple systems. If we are picking any one functionality, we want to modernize that into the new system. We should make sure like the integration with other system is not impacted. If that get impacted, then that will be a big impact. And testing and validation, since we are going to rewrite from the scratch, the testing will like a huge amount of effort required for testing, also the validation. And fourth one is data migration. So data migration from mainframe to the new system, obviously the data will be the huge volume. So if any loss on the data migration, that will impact the business operation. Even I added here the disruption to the business operation. Even if we even for example we are working on some modernizing one functionality, we didn't provide the file to downstream due to some issue on the new system. We didn't provide the data to downstream, so that will impact the business operations. And budget and time constraint, since we required lots of resource for rebuilding the application, and even it will take more time. And we will see one use case, how we can modernize this. For example, here we have application A, B, C, D, E, F. I given some sample names. All the applications are in mainframe DB2 only. All are consider all are batch application. We will
Mukesh,
see how we can.
Mukesh,
Yeah, yeah,
sorry for interrupting. Hey
yeah.
guys, are you able to see the PPT properly, the entire image? If not, we'll ask adjust accordingly.
Yes, sir.
Yes, we are able to.
Others,
Yes, I can see.
Yeah,
Yeah,
we
we
are
can
able
We
to
can
see
see
see.
it.
the entire. Not
Yes,
able to
it's
see the
very
there.
good.
heading.
Okay,
Yes,
fine.
any
If you are
heading
able
is
to
in
see the
highlighted
entire
part.
diagram, well and good. No problem. Yeah, go ahead. Sorry. Go ahead.
Yeah. Thank you.
No,
So
is there
in
any
this
heading in that?
diagram, yeah, sorry.
Is there any
There is no
heading in that?
heading. No, there is no heading here.
Okay, okay. Then I think there should be
Yeah,
fine.
yeah. So in this diagram, we have the multiple application A, B, C, D, E, F. I given just an example name, sample name. So all these applications are, I like considered all are in batch application. So all are in DB2. So how we can modernize this application into the modern system? We will see that. So first, for example, consider we are working for application C, which is on DB2. So when we start working on this application C, the blue is in legacy, blue is in mainframe, and orange is in the new system. So we should start analyzing the DB2 tables, whatever tables we have, we need to start analyzing that. And we need to build a new table structure in the new database. It can be anything. I just give an example Oracle. It can be any database. we need to build a new database structure whichever column is needed, and we are start doing the data sync between the db2 to oracle. For example, in the application c db2 we have the ui. On top of this application c we have the ui. What we need to do, we need to do the data sync, and we need to start building the ui on top of this new database. Since we have the data here, the whatever data we are getting from upstream, it's getting synced here, we have data here. We need to start building the ui on top of this application c. That is like when we have ui. And if I go to the next step, for example here application a is on db2. They are also planning for modernization. Even they are planning for to go with oracle. So they are start providing the data in the Kafka. So Kafka is like similar to MQ, which is used in the Java. So they are providing their data in the Kafka. So what we need to do, we are anyway, since we build our we build our database here, we need to build our application to consume this data and update in Oracle DB. And we need to start comparing this data with the db2. We can't we got the data, we can't turn off this integration because we don't know the uh, quality of data, whether it might be the right data, there might be some changes, some conversion is missing. So we need to do the data comparison between the oracle and db2. When we do the data comparison, when we do run some reports on everyday basis, we will came to know like, oh, these are the discrepancies we are seeing between these two application. We can ask the application a to correct this data. Might be this might be the expected, or this might need to be corrected. So all those things we need to correct it. And once we are feeling like, okay, data is looking good, the data whatever we are getting on the new route, it's matching with db2. When we are in that state, we can build an integration. We can build an integration to db2, from oracle to db2. Why we need to build integration means, because the from db2 we are creating multiple mainframe files. So if we didn't update the information to db2, we will miss sending the data whatever application a is giving to us. So it will create a lots of issues. So whatever data we are getting here on mq, we should get same data, and that should go to, the same data should goes to the downstream application. The currently whichever application we are sending, they should get the same information. For example, there are some 10 jobs. For example, there are 10 mainframe jobs which is reading data from MQ and updating DB2 directly. So one of the jobs is creating some mainframe file which directly goes to any of this system. Even before data comes to DB2, we are creating mainframe file somewhere here. So how we can create that file? We are going to sunset this flow, right? If we sunset this flow, how we are going to create that mainframe file? We need to see that file. If we are going to create one or two file, we can create that file from Java only. Anyway, we are getting data from here. This is the Java application. For example, we can create that file with Oracle data. Whatever data we have in the Oracle, we can create that file with the data, and we can provide that mainframe file. For example, that whatever files getting created in this flow, it's many files getting created, 10 files or 20 files getting created. It's like a very huge task creating those files from Java. In that case, one other approach is like, we can write this data into the Kafka. So whatever the application A is writing the data into Kafka, we can write it from here. From the Oracle DB, we can get the data and we can write it to Kafka. From Java, we can do that. So once the data is available in the Kafka, once the data is available on the MQ, the same set of mainframe jobs will execute. It will create the necessary output for mainframe files. Also, it will update the DB2 tables. if if we are planning to update directly from this from this Java application to the db2, then we need to make sure we are updating all the tables. Whatever tables getting updated on this flow, we need to update all the tables with the same information. so that the downstream files will be get generated with the correct information what is happening currently. The same thing will be generated in the future also. So once this integration is done, then this integration we can stop it. We can stop receiving the data from MQ on the application here. Since we are getting it from the Kafka, so we are syncing that information to DB2. So our business is continue running it. So we stopped this integration. Now, one of our downstream, for example, application D, they are planning for migration. So they build their own new application parallelly, and they are started. We can provide our data from the new source. So we have the build our new system right here. From here, we can provide our data to the application D. It might be from Kafka, or we can give some API. Whatever choice they are requesting, we can provide it in that way. For example, in that only application D is modernized, and application E and F, they are like their applications might be very complicated, or their modernization timeline is different. So until they are coming to the new system, until they are building their modern system, we have to continue providing the mainframe files. So here for application D, we are providing the data on the new route. Also, we are continue providing the mainframe files. So until they say your data is fine, so you stop sending the mainframe files. We have to provide the data on the new route. That is in this route. So when the next step, even application B also wants to modernize. Application B is building the parallel system. They wants to modernize their system, so they are giving on API. So you don't consume data from instead of mainframe file, you consume it from API. They are giving on API. So we should start getting the data from API. We can we update this data directly to this DB, because we are updating, we are sending the outbound to application D. They are start consuming this data. So we should not directly update until we know their data is accurate. If their data is accurate, if the test result, if the testing is, if the business is okay with the data from application B, then we can directly update here. Or else we need to build a new schema or new table. We need to store this data separately. Whatever data we are getting it from application B, we need to store it separately, and we need to do comparison between Oracle and C. Obviously, obviously for DB2 we are getting the mainframe file right from application B. So we need to do the comparison, and once the data is fine, once we are feeling like the data quality is good, then we can stop this integration also. So now application A, this integration we modernized, this in a two upstream system integration we modernized. Both are coming to Oracle, but still we need to support DB2. Still we need to run parallel system, because we are still generating mainframe file. These two systems, these three systems are not ready to come to our new source. So in the next step, application D says your data is looking fine for me, so I am going to stop using your mainframe file, so you don't generate a file for me. So in that case, we can stop generating file for them. Might be certain few set of jobs generating mainframe files for application D that we can deactivate, but still application E and F still running on mainframe. So still we need to support DB2, and still we need to generate mainframe files for them. And in the next step, application E wants to modernize, and application F also wants to modernize. They are building their system parallelly, and they might be doing the comparison with our data, whether we are doing all the transformation or data messaging, whatever is happening currently. Are we doing current everything properly? They will be doing their validation from their end. They might be running parallel system, doing data validation for certain period of time, and once they feel like our data is good, then they will stop using mainframe files. Application E stopped using mainframe file, application F stopped using mainframe files, And the one final dependency is now all the upstream is modernized, all the downstream also modernized. And now we need to see, are we updating any tables? There are like for example 10 tables we have in application C. Is anyone is consuming that data from that table? We need to see that. If any other application or any business users might be reading data directly from the table, so all those things we need to identify. And if no one is using the db2 tables currently, for example, if business user or some application directly reading the data from db2, we need to tell them like, we are not going to support these tables from so and so date. You come to our new source. We have our data in the Kafka or API. You use this new source, and they have to build their application, and they have to come to our new integrations. So once all the dependencies resolved, no one is using the DB2 tables also. In that case, we can stop this data integration also. This integration should be stopped since we are getting the data here. This integration should be stopped. Once no dependency on the DB2, this integration also we can stop it. By that time, the DB2 is like we are completely out of DB2 and completely out of mainframe. Any questions so far on this?
So I have one doubt, like how are you comparing this Oracle data with the DB2 data? Are you comparing in mainframe itself or when utility?
No. Yeah, good question. Like the comparison, like we need to build some application in Java itself. So that Java application should read the data on DB2, the JDBC connection, and also it will read data on Oracle, and it will do the comparison. Might be between like every day or every hour. So it should be from Java application, but mainframe it will not read data on Oracle as per my knowledge. So we have to build it on Java. Might be we are building some Power BI report or email trigger or whatever. That is up to our choice.
Because some other, you are saying some other independent system or application. So,
Sorry,
so the
what? Yeah.
comparison happens not in Oracle, not in DB2. It's some other application, right?
Oracle means the application we are building on top of Oracle, right? We might be building Java application on top of Oracle.
Java there. Okay, okay.
Yeah, it can be the same Java application. We can build
And they
on
can connect
parents.
to
But
the DB2 also.
yeah, yes.
Right. So the comparison is the manual process, right? Like whatever the
No,
mainframe file.
mm,
Yeah.
you are saying like this data comparison between Oracle and DB2?
Like for example, if mainframe has generated the output file and our modernization Java code also has generated the output file. So how we are going to compare it? Is it a manual or is it some tool we have by means of which we can compare it, or is there any other code we have to write it in order to do the comparison?
Like data comparison, the best way is we can do it on the database only. So Oracle DB, we have the data.
Agree. But like if
Yeah,
there are
yeah.
some reports getting generated, which will be used by business, so how we are going to compare that report, whether that report has came correctly or not?
Okay, but if I'm wrong, the source for that report should be on the table only. One thing is we can compare the tables, and second thing, if we need to compare the report, I think that will be a manual process. If we want to verify the reports,
Okay, so
as per I
manuals.
think my knowledge, it should be a manual process.
Okay.
Yeah.
It is more or less taking the connection, disconnecting the connection from mainframe and doing the connection from other source, right? If data
Yeah,
is
correct.
correct.
Yeah.
Yeah.
Because we can build, for example, we are getting data from two application. If you can ask like why we can't build both completely whatever is happening in the DB2, completely can we build it here and completely stop these two integrations, mainframe integrations of A and B, compare in a single time. Why we have to do one by one, that is also can be asked. But in that case, if any issue happened, it will be like we might get many issues. So
But
here
in this
like we
case,
are
we
going,
have to,
yeah.
yeah, in this case, we have to study all the programs which are a legacy system in mainframe and as
Yeah.
well as the new technology, what in the modernization we are using that we have to know. Then only we can do it, right?
Yes, yes, yeah, correct. The first step is we need to know what is happening on mainframe, what are the functionalities we have, what are the validations we have, and do we need all those validation in the new system. All those things need to be discussed with the team or product. So we need to come up with the conclusion. These are the things we are going to rebuild. These are the things needed for current business process. So only those things we are going to rebuild, because the mainframe will have mostly the redundant code or unused codes. We can see many. So those kind of things we can eliminate.
So, but there could be some batch jobs running right on this DB2. So, are you decommissioning those jobs, or that those will still continue once this?
Yeah. Let me go a few steps before. For example, we started consuming the data on this API from the application B. There are certain mainframe batch jobs running to process the data from this application B to C. So once we are getting data from the API, we can sunset whatever jobs running right in the flow. All those mainframe jobs we can sunset. So that required, like we need to make sure from this integration we are not generating any output file that is goes to any other system. For example, the job is reading data from the application B on from the DB2. It's creating few mainframe files. That file used by some other application ERF. We need to make sure we are generating that file, because we are responsible for that for generating that file. So here I added, like after DB2 I added mainframe files. Might be these files getting generated with the data from DB2. But here, even before data going to DB2, we are generating the mainframe file. So one option is like we can create that mainframe file from the with the data from Oracle. From Java, we can create a mainframe file. We can write that mainframe file. That file can be consumed by whichever system whoever is using that. So basically, the current flow should not be impacted, because we the every application will have their own timeline on the modernization. We Our application is complex, but application is very complex. They require lots of time on the modernization. So until they come to the modern system, we have to support on the existing route. We have to start providing the mainframe files.
One more
Ultimately,
question.
the business should not impact, right?
Yeah, correct.
And one more question, like how we are going to do this modernization? Is it a manual process, like because we have are we going to use any tool here, like CloudFrame or as AWS Blue Green, so Blue tool, or is there any tool we are going to use it, or is it like manual process? We are going to write a Java code, to convert whatever the Java business logic or technical is there into Java code and then do the modernization.
Here I don't have any experience on the tool. As per my experience, like studying the process, what is happening on the mainframe, and build that same process in the new system. So everything is manual.
Okay, so
So
but that's a time-taking process, right? That's a
yeah,
huge time-taking process.
yes. It's a time taking process, but in the, if we convert the mainframe code as it is to Java, then it will be like if we have 10 programs, it will create equivalent 10 classes, but we not needed all 10 classes. We can achieve everything in one class. So once if we are converting this mainframe code as it is to Java, I think optimizing the Java code also will be very complex, because it will write as it is what is there in the mainframe. Might be that can be
So
also
whatever,
executed as it is, but if we
okay,
need to
whatever
build
the append is
optimized
there,
application, yeah.
yeah, whatever the append is there in mainframe, like a SOC 7 or a SOC
Hmm.
4, other issues, same issue will occur in Java also. That's what you're trying to say.
Yeah, like data exceptions can occur in Java also, but that is
Hmm.
handled in Java. So in mainframe,
Okay.
if any SOC 7 is happening, right, so job will stop then and there. It will not proceed further until we resolve the issue. The job will be in failed status. But in Java, we can handle that. If any incorrect data we are getting, we can trigger an email to the concerned person. Might be the upstream is application AI is sending data to us. They are sending incorrect information. So instead of failing the process, we can generate an email to the application here saying your data is incorrect, and we can proceed further for next data. So a Java application will never stop for any exception. It will continue process, but it will generate the exception and send out an alert. Whether it can be on the email or it can be any other alerting mechanism.
One more thing, like no,
Yeah.
see, we are not using tool or anything and manual process. Then how you are going to handle this comp variables?
Yeah.
Because it will be a tedious process, right? In Java,
Yeah.
it's very difficult.
Yeah, correct. So comp variable, like for example, we are going to create a file, mainframe file from the process. We need to create a file. So for example, in this process, we are creating one mainframe file. Since we are getting the data on API, we need to sunset this process. Also, one of the mainframe file will not be generated. This file used by application E, for example. So in that case, we need to generate this application. We need to generate this mainframe file for application E. So in that case, we need to write this file from Java with the Oracle data. So this file is having comp variable also. In that case, Java will not be able to write comp variable, comp3 or comp2 or comp variables. It will
Yeah.
not be able to write that. Java can write only the ASCII format, only the readable format. So
Hmm.
the conversion need to be taken care on the mainframe only. So mainframe, we need to write some sort or program. We need to write some sort step or COBOL or whatever it is. We need to read that readable file and convert it into the required format. That is one thing we need to take in career.
Okay.
Hi, Murugesh, Srinivas here.
Yeah, hi.
So, can you initially what are the challenges you have faced, Murugesh? And can you share your experience like with modernization?
Yeah, like the challenge is like to understand the mainframe system is the big challenge. So there are
Yeah.
very complicated application. So we need to understand when we started analyzing the programs or tables, we will get lots of questions. Why this was coded in this way? Why that was coded in this way? But we will not find the right resource to answer that question. So we will
Okay.
find lots of challenges, and
Okay.
the validation what is happening on the mainframe, we need to decide whether we needed this. We might get many issues because we are going to build it from the scratch, right? So
Yes.
the testing effort will be very high. Also the validation will effort will be very
Yeah, and technical challenges, Murugesh, like how you guys trained and
high.
developed the applications. So initially, how
Yeah,
was it?
yeah. Technical challenges like the data load will be high on the mainframe. So handling the data load, we need to build. Initially, we plan the application for small amount of data. It will like in the Java we might get issues. So the data load will be very high, and that will be one challenging. We need to process all the data. What 10 millions of data we have in the mainframe. So the Java application we need to build in a such a way like it should process all the 10 million record.
Okay. So, and what are the technologies you guys used in your modernization project?
Technologies, it's for my experience we used Java and the database Postgres. So it's like completely Java, mainframe to Java. That is my experience.
So
And
you guys
and
handle
where
the
we are going to run this Java code? Is it will be in cloud server or it will be in on premises?
Yeah, it will be the own server on premises.
On
So
premises server.
that's how
Okay.
we planned. Yeah, so, but it's like in the depends on the team actually. Some applications using the cloud. but based on the project, it's varying actually. Some of the applications using on-premises, some of the applications still looking for cloud and they're trying to migrate it to cloud. So it's like varying, depends on the complexity of applications.
Okay. And one more thing, like normally these mainframe applications are like legacy application and used by like huge big organization like Citibank, Bank of America, or if we come to retail part like HBC, Walmart, and everyone is using. So at that time, in the month of November and December, there will be huge sale if you compare with
Yeah,
retail
yeah.
business. So at that time, how are you going to handle this situation? Because like when we talk about on premises, the servers are running on premises, the load will be
Mhm.
huge. Inframe has that
Yeah.
capability in order to process the huge data, even if it is 4 times or 5 times at that time, when like Black Friday or anything, it can handle it. But if you compare the Java servers and everything, that don't have that much capability in order to process huge amount of data. So if you are running it
Yeah.
on premises, how are you going to handle the huge amount of data?
So for especially on the peak times, so we will not be deploying anything. Most of the organization will do the same thing. So in the peak time, they will not deploy any changes to the their
I'm not talking
system.
about. I'm not. I do understand. I'm not talking about the
Hmm.
changes. I'm talking about the process. Because see, normally at that time the change will be freeze, so no changes will be
Hmm.
going at the time.
Yeah,
But
yeah.
my question is how the huge data will be handled by the
Yeah, in that
on-premises.
case, yeah, in that case, the period to those freeze period to that peak period will be load test will be performed on this Java application, like processing some like dummy data on the lower region. For example, usually this application will process 1 million data on every day. So we are
Mhm.
suspecting like in the peak period, 10 million data will come. So the
Mhm.
load test will be performed on the lower region. So to see whether the application will be able to process those data. If not, can we increase the memory, CPU? All those things will be taken care.
Again, increase in CPU again, it will cost huge, right?
Yeah, yeah, correct.
Questioning. Because if you go for cloud and everything, we can have a load balancer, load
Hmm.
distributor, and everything is there. So on premises, are we adopting those that feature in order to the load balancing?
I'm not exactly sure on that. It's on the Java end. So, like, as per my knowledge, like, load test will be performed, and based on that, any memory or CPU need to be increased. That will be increased.
Okay, fine.
Yeah.
Yeah, Sridhar here. Okay, for this application, this is Venkat. Okay, I for this
Yeah, hi.
application, what he is doing, I don't think so. They are implementing a load balancer in the cloud because the entire picture what is shown, the architecture, whatever he explained in high level, the entire flow is more of Java. Okay, so
Mm.
more of Java. Yes, if there is a cloud integration is there, yeah, there will be a load balance. Obviously, it should be there. Okay, cloud when you are opting the cloud, so to optimize the cost and everything, yeah, uh, load and load balancing, auto scaling will be there.
Yeah, okay.
Yeah. Thank you, Venkat. Okay. Any other questions?
This conference will now be recorded.
Murugesh, this is Amrita. My question would be, this is looks like a whatever you are doing is a complete manual rewriting of the code from mainframe to Java. But have you considered any other options? Because I know it's a very tedious job. Because I mean, it depends upon the complexity of the mainframe application. But if it is too complex, writing a whole code newly in Java uh, it requires a lot of effort, and there is a chance that a lot of errors or issues might creep into the newly written code. So have your team or yourself have considered any options where you can minimize writing the whole code manually? Is there any such thing considered even before you started? I understand that you have taken the manual approach, but before taking this approach, have you considered these scenarios like, okay, are there any other options where we can, migrate the code from mainframe into Java in an easier way and with a defect-free way?
Yeah, in my experience, I found like the application is having the mostly having the redundant code, and even the database is having the redundant information. So we didn't consider any option like any automated process of migrating those migrating the mainframe code to the Java. So like completely my experience is like following writing it from the scratch from understand what is happening on the mainframe and rewrite one by one functionalities rewrite from the scratch. So obviously we followed some automation for analyzing the mainframe component, like some tool will read the mainframe code and it will do the flow diagram or something that will be like easy to understand the mainframe code what is happening on the mainframe. But from rewriting to the Java, it's like completely manual only. So as per my knowledge, there is no tool used.
Okay, thank you.
Yeah.
Yeah, hi, Murgesh, Shoaib here. So I have a question. Like when we say we are going to like migrate changes from the mainframe to Java or any other application, right? So there will be two different application SMEs and developers, right? So what exactly like mainframe SME is doing? Is it just analyzing the code changes and talking about the like process to Java team where they are doing a code and we are doing some parallel testing? Is it like that? I'm talking in a general, like if you consider
Mhm.
about mainframe, like modernization. What will be the role of Java mainframe SME or developers here?
Yeah, here like for mainframe developer, the primary work will be like understanding the mainframe code. So what is happening on the mainframe? Even it's like COBOL or COBOL or JCL or even analyzing the tables. Like mostly analyzing the mainframe is on the mainframe resource and working with the Java team. These are the things happening in the mainframe, and even mainframe resource can extend their skill on the design also. So this is what happening. So these things need to be done in this way. They can extend their skill for design also to the new technology. For that they should have like at least high level knowledge on the Java, like at least some basic knowledge what is Kafka, what is API, how this all works. So if they have that knowledge, usually they can work since they will be knowing the functionality very well. So these are the things.
Okay, okay.
Yeah, even the mainframe resource, if they have knowledge, if they extended their knowledge on Java, they can work on Java development also, because here they will get more opportunity to work on other technology. It can be Java or .NET. For example, we are working on the migration for .NET. The mainframe SME is parallelly learning the .NET. They will get lots of opportunity to work on .NET since the migration is happening on the same team, right? The same team member will be working on the development. And even for the testing role, a mainframe resource will play a major role on the testing with the cross-functional team and validating the data, like since they know the data on the mainframe how it is, so the testing mainframe resource can take easily, they can do like effectively.
Uh,
Okay.
uh, Hi, I have one query with respect to the modernization. Okay, in mainframe, the CICS model also can be invoked using a Java, right? Java also. We can install a class and we can use a link. So can we use that method to validate for some time rather than executing on the mainframe side? We can also invoke the actual module in the Java itself. Right? Is it possible?
CSS I don't have any knowledge, sorry for that. I think I am not right person to answer. But my suggestion is like if we are going to modernize, we can rewrite that UI if it is in the CICS. Might be we can rebuild that UI in the new technology on top of new database. So that will be the better might be my suggestion. But invoking the CACS from Java, this I am not sure, not aware of this.
Okay.
Uh, I think whomever is the question with right CACS, yes, it is possible. We have recently done a project with converting a CACS screens into a SAP front end, so it is possible.
Yeah,
Okay.
thank you.
Yeah, hi Murugesan. This is Murthy. Can we use generative AI to convert the COBOL code into Java code?
Generative AI, even sorry, I don't have experience on that. Even it's a new for me. Generative AI, I need to see what is that.
I think Gen AI, Gen AI don't have that capacity, to convert COBOL to Java.
Okay.
We don't have. Still, they have not come up with that no advanced feature because COBOL is a not COBOL or EasyTray or SAS or
The
This
IBM
conference
has
will now be
IBM
recorded.
has come up with the Watson X AI, which will convert the
Watson X. Yeah, agree. But that's a
yeah,
tool. But it's a tool. But that's
tool.
not a Gen AI. Yeah, it's a tool.
Okay,
IBM Watson is one of the tools. They have
correct,
their
correct.
own product. They are still no. I went through that station, but no, that's very much complicated as compared to CloudFrame. CloudFrame is one of the you can just search in Google CloudFrame. It's a very easy tool where we can do the conversion compared to IBM Watson.
Sorry, can you
IBM
repeat
Watson
what is
or
it? Cloud frame.
CloudFrame.
Cloud frame. Okay.
Yeah, CloudFrame, and even AWS has that one. AWS Blue, I think, they have their own tool which will convert the COBOL to Java, Spring, and even platform. Everything that will handle it. So just some software we need to install and do it. But again, IBM is very much complicated as compared, and they are still working on that one. They are still doing the implementation in the IBM version.
So this cloud frame, do we have any IDE or can it be done in any other platform? Uh,
Means I didn't get.
so if to use cloud frame, should we bring our
Mhm.
COBOL code? See, we have COBOL code in our Endeavor or TSO, right? Should we bring that into any IDE and then use cloud frame or?
Yes. We have to. We need to install some software on like how we install our software and everything in Windows. Similarly, we have to install the software, no, some applications and everything in the mainframe system. That will going to convert. That then we need to download our code, and then we need to give input to the no, the product which they are developed it. So that will going to convert the COBOL code or whatever the JCL script and everything into the required Java code and the Spring Boot or whatever thing we needed. But as of now, everything is restricted to COBOL. They don't have any feature for EasyTree or SAS or assembly language code or any other Lexi codes. They don't have any feature. Only they are restricted to COBOL. It can be even IBM Watson, it can be a CloudFrame, it can be AWS. Everyone is restricted to COBOL. I hope I answered the question.
Okay, yeah, thanks. Yes.
Yeah, thank you. Okay. Do we have any other questions?
Yeah, so thanks again, Purgation, for coming forward and delivering session, sharing your knowledge successfully. Thanks for that. Thanks, guys who participated. I hope you gained some knowledge from this session, and you also asked wonderful questions. And yeah, so thanks for all of them. And in a similar fashion, as I said starting, I'm repeating again. If somebody want to give 30 minutes, 1 hour or 2 hour session on any topic, so please come forward and deliver. I will take care rest of the things. Okay, bringing the participants, all the things I'll take care. Okay, everything I need only from you, so I need to, because I cannot deliver everything, right? I have only my limited skills. And so you might be having some experience on something else. Whatever you can, you do it. Okay, if you are not able to do, you can check with your friends, whoever is interested, so that we can, you know have a weekly or monthly, once or twice, this type of sessions. We can have a, knowledge sharing sessions. Thanks, guys.
Yeah, thank you.
Jason, you want to say anything before we close the session?
Yeah, I like to thank you, Venkat. Thanks for organizing this, to talk in the big forum. This is a very good, discussion, very interactive discussion. I felt. So thank you all for whoever participated. So please contact me on in my email if anything, any clarification, anything needed. Yeah, thank you.
Murugesh,
Yeah,
what's your
guys, if you
LinkedIn
have any
ID?
queries, yeah, you can open the notepad and share the LinkedIn ID. That also works, so that others can connect.